You going or not? Okay. Yeah. Okay. Bye.
So good morning again. Just mute yourself as you come in, and we'll be started very briefly. Good morning.
Good morning.
So to Elijah, Esther, and Eric, just come back in the 6th grade chat tomorrow morning for homework check since you're in my advisory. Today you didn't have to. You're good because there was no homework.
Okay.
And then just good morning, everybody. Just make sure you mute yourself as you come in.
Okay.
All right, good morning, everyone.
I'm going to make you the host, Mr. Amador.
Thank you. So what I'm going to do is I'm going to share my screen so that everyone can follow along on the PowerPoint video for today's lesson on volume. Let's see. How do I disable chat? Let's see. All right, so shortly, you should all be seeing a PowerPoint on your screen. Give me a thumbs up if you see a PowerPoint. If you see a PowerPoint slideshow on your screen, great. Okay, so in your last session, we learned how to calculate the volume of rectangular prisms that have sides which are fractions. What we're going to do is we're going to start off with this review. So I know there may be some of you who do not have a packet. What I would like for you to do is look at your screen and begin the review questions, which are on the screen. You have 3 minutes for the review. Go ahead. Good question. Yes, you are allowed to use calculators. If you don't have a calculator, you can use a calculator on your phone or on the computer. But I think that everyone should be able to multiply these numbers out by hand. So we're going to take one more minute on this review. Whoever's doing that, was that me? Okay, in 10 seconds, we are going to go over the review questions. 10, 9, 8, 7, 6, 5. Joseph, if you're able to get your camera working, do your best to do that. 5, 4, 3, 2, 1, and 0. All right, all eyes on the screens. We're going to go over, take a look at the answers to these review questions. So using the volume formula for rectangular prisms, for each of these, what you would do is you would take the length, you would multiply it by the width, and you would multiply it by the height. This question asks to round to the nearest hundredth, which is why this answer we have to round to 0.16. So in last week's lesson, we all learned, I mean, it's been over a week, but in the last lesson, we learned how to calculate the volume of rectangular prisms with fractional sides. The volume formula is that volume is equal to length. Now I'm going to call on some people to finish this for me. So we're going to multiply the 3 dimensions together. Lemuel, I'm unmuting you. What is one of the dimensions that we have to multiply together? Go ahead, Lemuel, tell us one dimension.
2.
So what types of dimensions do 3-dimensional figures have? A 2D shape only has length and width.
The length and the width and the height.
Okay, so Lemuel just gave it all to us. That's great, Lemuel. Length times width times height. So this question here is asking us, it says how many 1/4 inch cubes would it take to fill up half of the prism? I can see here that this, we need someone to mute their microphone. Oh, Lemuel, it might be Lemuel because I left Lemuel. There we go. Thank you. So we can see that this is 3-dimensional because we see that there are cubes in basically in 2 layers. We can see that there's a front layer, which is I'm drawing on, which I'm trying to draw on right now. We can see that there's this front layer, and we can see that there's also a back layer, which I just drew on the side, a line that's on that back layer. This up here is the back layer. In order to find, in order to be able to answer this problem, I have to ask myself, what is it asking me? This problem is asking me how many 1/4 inch cubes it would take to fill up half of the prism. Now, I'm thinking to myself, what does it, when it says to fill something up, what does that mean when we're talking about filling something up? I'm calling on, let's go with Adelaide. I'm going to unmute you, Adelaide. What does it mean when we're trying to fill something up?
It means that we're trying to see like how much could go inside of a shape.
Okay. How much can go inside a shape? Great, Adelaide, that's absolutely correct. I'm putting you back on mute. Abriana, take it a bit further. So seeing how much something goes inside a shape, what geometrical or mathematical idea are we talking about?
I think it would kind of like go in between like the parts that we know of area or perimeter.
Okay, so perimeter is the distance around the edge of a shape. So I have this book here. The perimeter is the distance all the way around this shape. Great. The area, Abriana and everyone, is the surface, the space that is on this surface. So perimeter is around the shape. Area is inside it. So inside here on a 2-dimensional shape is area. I'm shading it in on the little picture that I just drew. But this figure here, this has 3 dimensions. So if we're gonna fill it up, Bintu, what is the property? What is the property that we are working on today? The focus of our lesson today is,
I think the focus of the lesson is, I think, has something to do with volume, like filling up the volume with half and 1/4. I think.
exactly. So we're looking at the volume of the prism. So filling this prism up means to find the volume that is inside it. I know that my volume formula is, I'm supposed to be able to erase these things. Oh, yeah, that's not good. So as of right now, no one is supposed to, as far as I know, we're not supposed to be able to draw on the screen. So it looks like there are maybe some other people who are able to draw on the screen. So I need to make sure that everyone does not do that. I'm going to work on finding a function that makes sure that we cannot do that. But if we're gonna have math class together, you're really going to need to be able to see the PowerPoints that I'm projecting. So I'm gonna need for everyone to keep your hands off of your devices, so that we're not all drawing on the screen. Yeah. All right. Let's go to, what I'm actually going to do is, I'm going to switch to my document camera and I'm going to finish working this out on the doc cam. Miss Scylla, I'm gonna actually break. I'm gonna break everyone out. I'll break people out into 2 rooms. If we can maybe just chat about what strategy we can maybe use to work on this problem while I get my document camera up. So, meeting participants. So actually, I should just do 1 room. So I'll keep 1 in.
Just make me a co-host, and I can do that part, and then you just get the document camera set up.
Okay, thank you.
Mhm.
Got you. Your co-host. Thank you.
Wait, I don't think I'm able to do it as a co-host. I think I will have to be the host in order to do breakout rooms.
Okay. Let me break them out now.
Okay.
Or breakout rooms 1, manually create rooms. Assign. Miss Scylla, I'm gonna put you in a breakout room. And I'm randomly assigning everyone else to your room.
Okay.
Alejandro, what strategy do you think that we might use to start solving this problem?
I think that we should probably turn the fractions into improper fractions.
Okay, that's a start. What are we actually, Naya, what are we actually being asked to do in the problem?
Oh, we're asking to be, wait, we have to multiply the length times the width times the height, and then we have to see if that's how, and then we have to see how much. Yeah, I don't know.
Okay, so we'll go over it as, we will go over this as a class. All right, great. I'm going to bring everyone back from the breakout room now. Breakout rooms, close all rooms. All right, show me a thumbs up if you see a blank piece of paper on your screen. Great. So we have this box, we have this rectangular prism, and its dimensions aren't exactly given to us, but we're shown the actual cubes that are in there. So I want everyone right now in your own papers, if you have them, to go ahead and count the number of cubes in the length, in the width, and in the height of the rectangular prism that you see. I'm still in the middle of drawing it. We got 1, 2, 3, 4, 5, 6, and 7, 8. Zenobia, how you doing? Let's get our eyes on the screen, or on our papers if we're working at our desk there. So our length is 8. We can see that the width it's only 2 deep. So this is 8 units in length. The width is 2 units, and the height, if we count 1, 2, 3, 4, 5, the height is 5 units. So again, you've been instructed not to draw on the screen, and yet people are still doing it. I'm going to tell you right now that there's a possibility that we can find out who is actually doing this. And if we find out that it's you, we're going to take this very, very seriously. As a network, we're doing our best to continue to give you an education, because you deserve to have a great education, and this is what we're doing in order to do that for you. So for anyone to want to play around and joke around and take time away from everyone's learning, it's irresponsible, and it's very disappointing. And you should take yourselves more seriously, so that you can get the best experience that you have from not the best situation. Okay. All right. We want to know what half of the volume, and we're trying to fit inside it cubes that are 1/4 of an inch. So instead of finding how much they can fill the entire volume, I'm only going to concern myself with half of the volume. So half of the volume, I will go ahead and I'll cut my prism in half. Maybe I'll cut it a slice right down the middle. I'll cut a slice right down the middle. And so now I only have that front piece. And so my new dimensions of my prism, well, let's see, my height is still going to be 1, 2, 3, 4, 5. My height is still going to be 5 units. My length is also still going to be 8 units. But now, because I cut it in half and I'm only using that front piece, my width is now only 1 unit. My plan to find how many 1/4 inch cubes, can fit inside is going to be to find how many 1/4 inch cubes fit within the length, the height, and the width. The width is only 1 unit deep. How many 4-inch cubes, how many 1/4 inch cubes can fit inside one? I want you all to think about it. Show me on your fingers, show me on your hands. How many cubes that are 1/4 of an inch can fit inside a depth that is 1 inch long? I see 4, I see 4, 4, 4. Yeah, exactly. So we can actually have 4 cubes in the width. In the length, we have to multiply that by 4 also. So 8 times 4, 8, 16, and then 32. 8 times 4 is 32. Show me thumbs up if I did my mental math correct. Okay. And the height, which is 5, 5 times 4 is 20, so I have 20 cubes. So inside my half of my prism, I can fit 4 cubes in the width, 32 cubes in the length, and 20 cubes in the height. I know that volume is length times width times height. So I have to multiply the 20 cubes times the 32 cubes times the 4 cubes. $20 times, you can go ahead and work this out on your own calculators. Let's see, 20 times 32 times 4. Anaya's got her hand up. Go ahead, Anaya.
I got 2,560.
I also got 2,560. All right, let's move. Everyone turn in your packets to the We Do. Are we seeing a PowerPoint on the screen share? Show me. No. Okay. So the screen share. How about now? Thumbs up. All right. Tyrone is moving. And everyone give me a thumbs up if you are with us on this We Do. Thumbs up. Thank you, Miss Silla. Elijah is there. Sonovia is there. Nana, are you with us in the We Do? Give me a thumbs up. Silent thumbs up. Quincy, you can follow along on the video. Okay, the We Do is what I'm putting up here on the video. Yes, Quincy, you're unmuted.
The thing is, I don't have my packets and I'm only using my notebook.
That's right. We discussed this morning, so you can follow the We Do on the screen. Are you able to see it?
Yeah.
Okay, so copy down the problem on your paper. Excellent. Tyrone is moving, and he needs to pack the remainder of his belongings in the box below. So we've got a picture of a box. It has dimensions of 6 1/2 inches in length, 5 1/4 inches in depth, which you might call width, and 5 1/2 inches in height. Tyrone wants to pack a picture frame that measures 6 1/2 inches in length, 5 1/4 inches in width, and 1/2 an inch in height at the bottom of the box. What fraction of the space inside the box will be taken up by the picture frame? Let's go to Joseph. Joseph, I am unmuting you. What is the problem asking us to do?
The problem is asking us to find the volume of the space. I mean the square.
Joseph, do you have, so let's all go, give me a thumbs up or thumbs down if you think that Joseph's on the money here. Are we looking to find the volume of the square? Thumbs up means he's got it right. Thumbs down, not quite. Are we looking to find the volume of this box? I see some people are not on the screen. Benju, please come back and join us. I see lots of thumbs ups. Well, here's what I'm going to do. I'm gonna highlight this section of the problem right here. What fraction of the space inside the box will be taken up by the picture frame? So this question isn't exactly asking us what the volume of the frame is. It's asking what fraction of the space will be taken up by the frame. So this picture frame, you can imagine, this is me drawing on the screen now. You can imagine that there's a picture frame that he's going to put in the bottom of this box. The picture frame has dimensions. The picture frame's dimensions are outlined right here in the problem. It has the same length as the box, and it also has the same width as the box. The width right here, it has the same width, except it's only ½ inch in height. So it's a little thin picture frame that they're putting in the bottom of the box. How does this change our understanding of what we need to do? Let's go with Anthony. I'm unmuting you.
What?
Anthony, how does this what do we need to find in this problem now that we've gone over what the problem is describing? I'm going to unmute you now. Give me a thumbs up if you're ready.
I think he can't hear you. I'm gonna chat
Okay.
him really
Yeah, I
quickly
see
and see
that.
what's going on.
Okay. Let's go to Kiara. You give me a thumbs up if you're ready. Okay, Kiara.
Okay, so I think that the length and the width, you're gonna have to multiply them in order to find the inside space of the picture frame, but I also think you have to multiply the height.
Okay. So the length and the width and the height of what?
Of the cube.
Okay, so we will need to find the volume of the box, of the cube box. Definitely. We're also going to need to know what the volume of that picture frame is also. So the volume of the picture frame is, so the frame is 6.5 times 5 and 1, 5.25, 5.25 times 0.5, because it's 1/2 inch in height. So I can find the volume, and we can all find the volume of this box. What I want you all right now to do is find the volume of the picture frame. We are all finding the volume of the picture frame. Give me a thumbs up when you are ready. Josue, your video is a little bit close to your face, so sometimes I can't see you when you, yeah, but I can see your thumbs up when you use the app, so that works too. All right. So let's see, we've got some participants are raising their hands here. Josue, the volume for the volume for the picture frame itself.
17 and 1/16.
17 and 1/16 cubic inches.
Yes.
Okay. So the frame is 17 and 1/16 cubic inches. Now find the volume. If we want to know what fraction of the volume of the box it is, don't we need to know the volume of the box? We need to know the volume of the box, don't we? So go ahead and find the volume of the box.
Naya has a hand up. And Naya.
Anaya, did we? Let's see. Can we? I'm scrolling through for Anaya to unmute her. There we go. Okay, Anaya.
17.0625.
17 points. That's the volume of the picture frame.
Oh, the volume.
The volume of the box. I'm gonna go to Silas.
187.6875.
Show me if you agree. 187.
I see Katie disagreeing.
187 point. Can you repeat that, Silas? Let's see, there's someone that we still need to, oh, Anaya, here you go. Okay. Silas, can you repeat your answer? 187 point.
6875.
6875. So we know now the volume of the frame and we know the volume of the box. We want to know what fraction of the box the frame takes up. How can we find what fraction of the box the frame takes up? Everybody think. Raise your hand. Let's see, we've got Eric has a hand raised. Eric, I'm unmuting you.
I think what we should do is that we should divide the volume of the box by the volume of the frame.
Divide the volume of the box by the volume of the frame. So when we want to know how many times something can fit inside something else, we use division. Go ahead and find how many times the frame fits inside the box using division. When you're finished, give me a thumbs up. We're gonna take another 20 seconds. Give me a thumbs up when we're finished with the problem. Nana's ready. Elijah's ready. Lysandra. Adelaide, I see you. Jessica. Esther's still working on it. Keep it up, Esther. Alejandro. Josue, I see you. Okay, we're gonna share out this answer. I'm gonna go to Nana. Nana was the first one I saw. Nana. No, Nana? Not confident? All right. It's actually time for our next lesson. So what I'm actually gonna do is everyone check. So if you divide 187, 187.6875. This is terrible. This is not going to work very well. Divided by 17.0625, you get 11. So 11 picture frames can fit in there. The answer is what fraction? So the answer will have to be 1/11. I want to thank everyone for bearing with us today on our first day. We're going to be troubleshooting some problems. I'm going to not take up any more time of our next lesson. So scholars, for tonight, work on your homework. Work on what's in the math homework packet. So today's lesson in your packet, the homework is homework, and we'll go over that tomorrow morning. Lamuel, I can talk to you at another time, okay? Anyone that has questions can talk to your advisors during the break times, and we'll figure things out.
Yeah.
Awesome.
Go ahead.
Okay, it's break time now, scholars?
Oh, so that's perfect. This is the perfect time for that.
Yeah, exactly. So you guys have break and then you come back for TA at 10:10. Your advisors might be checking in with you, okay? Okay, see you guys at 10:10. Thank you.
My advisory actually just
Oh, yes.
in here for a second. If you're in my advisory.
Yeah, so if you're in Mr. Prenia's group, please don't hang up. If you're in my group, I'm gonna text the chat right now so you guys can log off the chat if you're ready to go.
And my group, I'm also going to create a chat room for us, for my advisor group, and I'll text each of you that the ID number for the meeting.